All right, so we are on 11.7 today. So this is more probabilities. Okay, so now we're going to talk about what to do probabilities where you have something and something else both happening. So basically when you have and or you have multiple things, you want to know the probability of all these things happening, then you just multiply the probabilities together. So it says, suppose you draw a card from a 52 card deck. The card is then replaced and the deck is shuffled and you draw another card. So find the probability of getting a heart on the first draw and a spade on the second draw. So the probability of getting a heart is, that's 1/4 of the deck. So there's 13 of them, or you could just say it's 1/4. So either way, you can say it's 13 out of 52, or you can just say it's 1/4. So that would be a heart on the first draw. So you get a heart and then you put it back and then you draw another card. And you want to see what's the probability of that one being a spade. So there's also 13 spades. So that would be 13 out of 52. And we know that's going to reduce to 1/4 times 1/4. So you can put this just directly into your calculator, but it's pretty easy to do it without, in my opinion, because then that's just going to be 1/16. All right, so like I say, yeah, you can put it in if you wanted to put it in as 13/52 times 13/52, you could do that even on your calculator. Just use that ABC button as your fraction bar, the ABC button. All right, and what is the probability of getting both queens? So there's 4 queens out of 52, which also reduces to 1 out of 13. So 4 out of 52 times 4 out of 52, which also reduces to 1 out of 13 times 1 out of 13. And when you multiply that, it's going to be 1 out of 169. And you can do that on your calculator as well. All right. What is the probability of getting no queens? All right, so you want to get something that's not a queen. So the probability of getting something that is not a queen, well, there's 4 queens. So 52 minus 4 is 48. So there's 48 that are not queens. So 48 out of 52 times 48 out of 52. Right, 12 out of 13 times 12 out of 13, which equals 144 over 169. All right, so number 2, suppose you draw 2 cards from a 52 card deck without replacement. So on the first problem, you draw a card and then you see what it is and then you put it back in, shuffle the deck, draw another card. But for number 2, you're going to just draw a card and see what it is and then basically hold on to it and then draw another card. Okay? Exactly. All right, so find the probability of getting a heart on the first draw and a spade on the second. Okay, so probability of getting a heart the first time. So there's 13 hearts out of 52. And then a spade on the second. So you have that heart in your hand. There's still 13 spades in the deck, but now there's only a total of 51 cards in the deck because you've got that one other card already taken out. You're holding on to it. All right, so I'm just gonna go to my calculator and type in 13 ABC 52 times 13 ABC 51. And that gives me 13 over 204. All right. And then the probability of getting no queens. So the probability of getting something that is not a queen the first time is 48 out of 52. All right, so then you take a card that's not a queen and you have it in your hand. So now there's 47 cards that are not queens out of a total of 51 cards that are left in the deck. So 48 ABC 52 times 47 ABC 51 equals 188 over 221. We just talked about that.
This is the one before Thanksgiving?
Either before Thanksgiving or after Thanksgiving, depending on what we decide. What?
We don't have one till then.
All right, so then at least one queen. Okay, so the probability of getting at least one queen, that's going to be the opposite of getting no queens. That's like the complement of getting no queens. So what we could do, what we wanted, so the probability of getting at least one queen is going to be 1 minus the probability of getting no queens. So in other words, 1 minus the answer from the last part, which is 188 over 221. Oh, let me put that in my calculator. 1 minus 188 ABC 221. That's 33 over 221. All right, number 3 says, suppose a single 6-sided die is rolled twice. Find the probability of getting both 3s. All right. So the probability of getting a 3 is 1 out of 6, and then the probability of getting a 3 again is 1 out of 6. So 1 over 6 times 1 over 6 equals 1 over 36.
Why wouldn't you simplify?
There's nothing to simplify.
Oh, just kidding. I wrote 3 over 6. That's why I was like,
Okay, and the probability of getting no 3s. All right, so that's going to be, okay, probability of not getting a 3 is 5 out of 6 times the probability of not getting a 3 again is 5 out of 6. So that equals 25 out of 36. Okay, a 1 and a 2. So I'm going to insert the word then, meaning you get a 1 first and then you get a 2 on the second. So that would be probability of getting a 1 is 1 out of 6, and then the probability of getting a 2 is 1 out of 6. So that's, again, 1 out of 36. All right, number 4 says, suppose a fair coin is tossed 4 times. Find the probability of getting 2 heads and then 2 tails. So when you toss a coin, the probability of getting heads is 1 over 2. So probability of getting heads, 1 over 2. Getting heads again, 1 over 2. And then getting tails, that's 1 over 2. And then getting tails again, that's 1 over 2. So multiply all those together, it gives us 1 over 16. And the probability of getting all tails, so that's 1/2 times 1/2 times 1/2 times 1/2, which is 1 over 16. All right, and then the probability of getting at least 1 head would be equal to 1 minus the probability of getting no heads, which is the same thing. Getting no heads is the same thing in this case as having all tails, which is what we did on the last problem. So this would be 1 minus 1 over 16, which would equal 15 over 16.
How do you know when you do the one?
I guess when it says like at least 1 or something like that, then you're going to want to use that. Yeah. At least 1. So this kind of, if you think back to what we learned from chapter 3, at least 1 is like the complement, or like, we talked about the negation. At least 1 is like the complement to none. So that's why we do 1 minus. Okay. Suppose 65% of all adults are married. If 10 adults are randomly selected, what is the probability that none are married? So, all right, so 65% of all adults are married. That means if you randomly selected 1 adult, then the probability that adult is married is 0.65. And the probability that they're not would be 0.35, because we just subtract that from 1. So for 1 person, the probability that that 1 person is married is 0.65. And so that means that the probability that a person is not married is 0.35. One minus 0.65, which equals 0.35. All right. So if you have 10, if you randomly select 10, then the probability that all 10 of them are not married would be 0.35 raised to the power of 10, because you do 0.35 times 0.35 times 0.35 10 times, or in other words, raising it to the power of 10. So approximately 0.0000, let's say 28. Okay, conditional probability. So one way to think about calculating conditional probability is, so first of all, conditional probability is the probability of something given something else. Okay, so it's like giving you extra information at the beginning to kind of narrow down your probability. And so one way to calculate the probability of E given F, it's the probability of E and F divided by the probability of F. Or it could be the number of ways that E and F occur divided by the number of ways just F occurs, or the given. Okay. So yeah. So this is the same problem we had previously, but we're just gonna, now we're gonna do those questions where it says, you know, given something or other. So 96 people were surveyed. One person from that survey is randomly selected. Find the probability that the person is a female given that they are Republican. Okay, so that's gonna basically be E and F, or both of those things, divided by just the given. Okay, so female given that they're Republican. So there's 17 female Republicans divided by a total of 46 Republicans. So it's going to be 17 over 46. And that's, if we want the decimal, that's approximately 0.40. Or sorry, that's not right. 0.37. All right, what is the probability that they are a male given that they are a Democrat? Okay, so there's 22 male Democrats divided by 50 Democrats. So 22 over 50. I can reduce that to 11 over 25. Which is equal to 0.44. All right, and then what is the probability that they are a Democrat given that they are female? Okay, so there are 28 female Democrats divided by 45 females, so 28 over 45. And that's approximately 0.62. Okay. Number 7 says, suppose 2 cards are drawn from a standard 52 card deck without replacement. Find the probability that the second card is a spade, given that the first card was a spade. All right, so basically what they're telling me is like, I already know that the first card was a spade. So now knowing that, what is the probability that the second card is also a spade? Okay, so after I take that one spade out, there's now 12 spades left in the deck of 51 cards because I've got that one spade already in my hand. And that can reduce to 4/17. And let's see. Find the probability the second card is a spade, given that the first was a club. So if the first was a club, that means there's still 13 spades in the deck, but there are only 51 cards because you have the one other card already out in your hand. And that doesn't reduce, so. All right. So that's all. Yep. All right, so go ahead and do your homework for this section. The homework for this section, it should be due Thursday,
Okay.
but hopefully you do it sooner than that.
Remember they saw it print about
What we just did is
Yeah.
11.7.
We're gonna do 8 and 9 for the next quiz.
Um,
11.7, 8, and 9.